Okay. Am I audible? Not audible. Okay. Let it be. So, so let us start today's lecture with recursive sequences. Let us start today's lecture with recursive sequences. See, as the word indicate, recursion means what? Repetition. Okay, recursion means what? Repetition. So what is being repeated? So if I'm saying the general term of the sequence, in that particular general term, the previous terms are going to get repeated or previous terms are going to come. So those sequences are called as the recursive sequences. I'm just giving them a name. It's not even necessary that you should know this name, but fine. So subsequences whose nth term is defined in terms of previous terms, whose nth term is defined in terms of its previous terms. So if subsequences are called as the recursive sequences. Okay, so let us take one example. One of the example for recursive sequence. Let's say a recursive formula. A recursive formula, and generally it is called as the Newton-Raphson scheme. When you study when you study numerical analysis, you'll find that there's a Newton-Raphson scheme for approximating root over 2. So recursive formula or Newton-Raphson scheme of approximating root over 2. Okay, so let us take this. So let x1 be equals to some is equal to 2, and let us define the sequence xn by this. So clearly you can see that this particular n plus 1th term is defined in terms of xn. So a term is defined in terms of a previous term. So clearly this is a recursive sequence. We want to know whether this sequence is convergent or not. And if at all it is convergent, then where does it converge? As I already told, this is a sequence which approximates root 2. So one of the ideas is that the limiting value should be root over 2. Let us see how. Okay, so let us start. So if you just think what is xn plus 1, so xn plus 1 is written this. Let us first find whether it is an increasing sequence or a decreasing sequence or what. This is one strategy, that is to find increasing and decreasing. Another strategy is to see whether xn is bounded or not. So if I know from some way that xn is bounded, and from somewhere if I have this information that it is a monotone sequence, then from monotone convergence criterion, our sequence xn will be convergent. This is one of the ways to deal. So what I can do, I can simply find whether my xn is bounded or not, one, and also I can find whether my sequence is monotone or not. So if I find both of these things, then I can say that my xn is convergent. Okay, so this is one of the things. So what I'll do, I'll try to solve this up. So if I solve this up, what do I get? I get xn square minus 2xn plus 1 times xn, and then I will get, I think, this will go there. So I'll get plus 2 equals to 0. Clearly, you can see this xn is a real sequence, so xn belongs to R. So if xn belongs to R, so I can say that, and you can see that this is a quadratic in xn. You can see that this is a quadratic equation in xn. Okay, so this is a quadratic equation xn. So if you think this is xn ka square, this is minus 2 xn plus 1 times xn plus 2. So this is a quadratic equation in xn. And if xn belongs to R, then the solutions, so the solutions dictate us one of the things that my discriminant should be greater than or equal to 0. My discriminant should be greater than equal to 0. What does that imply? It implies simply that my 4 times xn plus 1 whole square minus of 8 must be greater than equal to 0. And from here, it's quite evident that my xn plus 1 whole square is greater than equals to 2. So I can clearly say that my xn is bounded below. Okay. Now, what extra information do I need? I need to prove whether my xn is monotone. So if I do this xn plus 1 minus xn, what do I get? Xn plus 1 minus of xn, if I do, I'll get 1 upon 2 times xn plus 1 upon xn minus of xn, which will give me 1 upon xn minus of xn upon 2. And from here, I'll get 2 minus of xn square divided by 2xn. I already know that my xn square is greater than 2. So 2 minus xn square would be less than equal to 0, and which would imply that my xn is greater than equal to xn plus 1. And it implies that my xn is a decreasing sequence. So here I arrive at a result that my xn is a decreasing sequence. Further, it is bounded below, implies xn is convergent. Xn is convergent. So, and if xn is convergent, I can simply find my limit from here. If I find limit from here, I can clearly see that if I say that my xn tends to L, so similarly, I can say my xn plus 1 also tends to L. So that this will be simply L square minus 2L square is equals to minus of 2. And from here, clearly L is equal to plus minus root over 2. But from the just observation, you can see that all the terms are positive. All the terms are positive. So L cannot be equals to minus of root 2. So therefore, the limit would be L equals to root 2. Is that clear? I hope this is an easy question, kind of book question only. Yes or no? Please let me know. So this sequence is called as recursive sequence. So at times you'll find in books written that these are recursive sequences. That's why I just wanted to show one of the recursive sequences. A little bit difficult example, probably I want to give at this stage itself. Okay. But let us first solve a few more questions so that. Okay. So we are doing problems on real analysis, and especially in sequences right now. So I'm giving let x1 equals to 1 and xn plus 1 is equals to n upon n plus 1 xn square for all n belongs to natural. We want to see whether my xn is a convergent sequence or not. So I want to see whether my xn is convergent or not. What do you think your sequence would be? Is it convergent or not convergent? One thing is quite clear, that xn square is positive, n is positive, n is positive. So one thing is quite clear that xn would be positive. Further, it is already given that x1 is equals to 1. So how would your x2 would be? X2 would be 1 over 2, I guess. Okay. So just place n equals to 1. You'll get 1, 1, 1 by 2. And x1 is 1. Simply x3 will be equals to what? It is equals to, just place 2 here. 2 upon 2 by 3. Sorry, if I place 2 here. So 2 by 3. And x2 square is 1 by 4. So one idea you can get, one idea you are getting that be whatsoever, you are finding that it is less than 1. So you can write here, my claim, you can claim that xn is less than equal to 1, or simply xk is less than equal to 1 for all k belongs to natural. This is what you can see. One of the things that quite evidently you can see that your xk is coming less than equal to 1. Okay. Now, if xk is coming less than equal to 1, this is my claim. This is true for 1. Clearly, x1 is equal to 1. We want to prove it for n plus 1, or you can say k plus 1. So xk plus 1 would be equals to what? It would be k upon k plus 1 and xk ka whole square. And I know this is less than equal to 1. So this would be less than equal to k upon k plus 1. And we know from here, in general, I will say xk is less than 1, or here if I want to write, I can write that xk is less than 1 strictly for all k greater than equal to 2. At 1 it is equal to 1, but otherwise for all k greater than equal to 2, xk is less than 1. So if I take this statement, for 1 we already know, it has been given to us. So if I write that xk is less than equal to 1, for xk is less than 1 for all k belongs, for all k greater than equal to 2. Now here if I see, if I write, this will be this way. And from here I can write that xk would be less than 1 upon, xk is less than k upon k plus 1, means xk is less than 1 minus 1 upon k, and certainly it is less than. So by principle of mathematical induction, it has been proven that xn would be less than 1 for all n greater than equal to 2. And further, I know that at x equal to 1, it is equals to 1. So in general, I can write my xn is less than equal to 1 for all n belongs to natural. So this is quite clear that my sequence is bounded below by 0 and above by 1. Is that clear? Now, I already know that my xn plus 1 is given by n upon n plus 1 xn square. So I can write this as n upon n plus 1 xn into xn. And I already know that my xn is less than 1. This is already less than 1. So both of these are less than 1. So I can ultimately write that my xn plus 1 would be less than xn. See, this is already less than 1. Understand, xn has been given less than equal to 1 in general, but otherwise for all n greater than equal to 2, it is less than 1 only. So this is less than 1, this is less than 1. Xn plus 1 in any case would be less than x. I hope it is clear. Y take k. Okay. Oh, it's not necessary. Okay, y take k. It's not necessary. You can take n also. It's just this is a matter of the fact that generally we use n here. So no issues. You can take n also. Don't worry. So if someone was asking why take k, no, not necessary. You can take n also. So, no issues. So in general, understand that xn is a decreasing sequence. Xn is a decreasing sequence plus xn is bounded below. So it implies that xn is convergent. Okay. Okay, this is clear. And one thing is very much clear. Now, if I want to find the limit, so limit n tends to infinity, let's say xn is equal to L. So similarly, limit n tends to infinity, xn plus 1 will also be L. So it is equals to L is equal to simply L square, because as n tends to infinity, this will go towards 1. So from here, there are two limits. One is coming as 0, other one is coming as 1. So what do you think the limit would be? What do you think the limit would be? Okay. See, this is quite clear that limit would be 0. Why? Because one thing is very much clear, that this sequence xn is a decreasing sequence. Since xn is a decreasing sequence, I can write that my limit L would be equals to what? It will be equals to infimum of xn for all n belongs to natural. And in general, it will be less than equal to x2. This is very much clear, because infimum xn would be less than equal to x2, also would be less than equal to x1 also. But then you will get confused because limit is already given. So if the first term is 1, the second term is 1 by 2, the third term is even more less, and so on and so forth. So you can clearly see that in any case, you can say that my xn would be less than equal to x2. I'll subtract 1 from here. Why I'm subtracting 1? Because this particular term itself is limit. So forget about this. Just think about terms from x2. So if I just think about terms x2, x3, x4, I can say that my limit xn, which is equals to, let's say, L, is converges towards infimum. And in any case, infimum would be less than equal to x2. x2 is what? Half. So you can clearly see that L must be less than equal to half. So it implies L cannot be equal to 1. So L has to be equal to 0. Okay, so I hope these questions are easy. So if these questions are easy, then should I go, should I move ahead? Are you getting these questions now? Okay. Okay. So these questions, I hope these are easy for you. Let us do a little bit. Okay. Okay. So now let us try to do, one more easy question let us do so that you gain some sort of confidence, then you'll see. So let x1 is equal to 3 over 4 and xn plus 1 is equals to xn minus xn raised to power of n plus 1 for all n belongs to natural. We want to examine whether my xn is convergent or not. Whether my xn is convergent. See, whenever in exam you get such questions, first thing you should do is try to write a few terms. So you already know that your x1 is 3 over 4. The next term would be 3 upon 4. The x2 would be what? It would be 3 upon 4 minus 3 upon 4 whole square. And likewise. So you can clearly see that in any case, xn would be less than 1 but greater than 0. The terms would be positive indeed, because you know that whenever x lies between 0 and 1, if I'm doing square or if I'm doing higher power, this number would be greater than this. If x lies between 0 and 1, then higher the powers I take, smaller number is. So 3 by 4 is greater than 3 by 4 whole square. In any case, all the numbers would lie between 0 and 1. Is that clear? Now, this is my claim. And it is quite clear that x1 is equal to 3 by 4. Certainly, 3 by 4 lies between 0 and 1. So it is true for 1. So my claim is what? PN claims that xn lies between 0 and 1. And if xn lies between 0 and 1, it is true for 1. That is x1 is equal to 3 by 4. 3 by 4 certainly lies between 0 and 1. If I make this claim true for xn plus 1, then I can certainly say that my claim is true for all n. This is through principle of mathematical induction. Okay, so what is your xn plus 1? Your xn plus 1, I think it was, okay, xn minus of xn raised to power n plus 1. Just take xn common out. You'll get 1 minus of xn raised to power n. Already it has been given to you that xn is less than 1. It has already been given to you that xn is less than 1, greater than 0. And similarly, you can say that xn raised to power n also would be less than 1, greater than 0. And if I write 1 minus xn raised to power n, again it lies between 0 and 1. It's quite easy to see. So this lies between 0 and 1. Clearly, I can say that my xn plus 1 would be less than xn. See, anything which lies between 0 and 1, if it's here, if I multiply by xn, so clearly it is going to reduce overall xn. So xn plus 1 is lesser than xn, certainly. And since the sequence is decreasing, sequence is bounded, it implies sequence xn is convergent. I hope it is clear. Good enough. Is there any doubt? Okay. So if things are, I think these questions are easy. I thought that, okay. Now just think about this thing. Now a little bit of epsilon del. Uh, okay, before doing that, I'll give some easy questions and then we'll take some difficult questions. I want to raise my level slowly, I think, because I found that questions are getting. See, what do you think about this sequence? An is equal to n upon 2 raised to power n. An is equals to n upon 2 raised to power n. What do you think this sequence is? Is it monotone? If it is monotone, is it bounded? If it is bounded, is it convergent or is it not convergent? So I'll give you the results soon, but just think about an plus 1. After all, whenever it's about us, whenever I ask you about decreasing and increasing, what you are supposed to find, you're supposed to find the difference between an plus 1 and an. Okay. And if it is positive, then I will say that my sequence is increasing. If an plus 1 minus an is less than 0, it implies my sequence is decreasing. So instead of this, it will be easier for us to take the ratios here. So I'll take a ratio, and lately we'll study something called as the ratio test also. But right now, before going to an advanced thing, let us do it in the easier fashion. So what did I get? I got that an plus 1 upon an plus 1 upon an is simply equals to n plus 1 divided by, I think this is 2n. Is that clear? This from here 2 raised to power n gets cancelled. 2 remains, n is already there. So clearly, I know that n plus n in any case would be greater than n plus 1. So I can write that n plus 1 upon 2n would be less than 1. Is that clear? So in any case, this is less than 1. It implies what? It implies that an plus 1 would be less than an. So your sequence is decreasing. Okay. Also, that from just observation, you can see that your an would be greater than 0 for all n belongs to natural. So sequence is decreasing. Sequence is bounded below implies an is convergent. I hope these are easy questions for you. Okay. So an is convergent. And further, if you want to find the limit also, you can do so. So your an plus 1 is equals to n plus 1 divided by 2n times an. And you take limit an. So your limit an is, let's say, L. So L is equals to 1 upon 2L. It implies L equals to 0. So clearly, the limit would be equals to what? Limit an would be equals to 0. Is that clear? Okay. Okay, so at times, if you're not able to directly think about an plus 1 minus n, just try to take ratios. And if you can make sense out of this, this will be good, one of the good strategies. Okay, so let us do a few more questions. And then I'll give you one easier method to solve all these questions in a minute or so. Okay, so one of the questions I'm going to give you from this. So it is again an example of recursive sequence. So let A and B be any two distinct real numbers, and let x1 is equals to A and x2 is equal to B. And we have defined xn plus 2 is in a manner that it is equals to xn plus 1 divided by 2. Okay. And we want to find whether xn is convergent. We want to find whether xn is convergent. Okay. So one of the ways to do it is using subsequences. And I have not taught you till now the subsequences. So I'll take the most basic approach. What if I prove that this sequence is a Cauchy? So I'll try to prove that this particular sequence is a Cauchy sequence. And kindly see the lectures on Cauchy sequences. I've done quite amount of good questions there, quite good questions there. Okay. So what is a Cauchy sequence? Just to recap, what are Cauchy sequence? A sequence is said to be Cauchy if xn minus xn modulus can be made less than epsilon for all n greater than m greater than equal to some m naught belongs to natural. Is that clear? So if you can prove that after some positive natural number, the distance between the two terms of the sequence also can be made less than epsilon. If this is the case, then I say that my xn is a Cauchy sequence, and Cauchy sequence in R are convergent in R. Is that clear? Okay. So what I'm going to do? What am I going to do? So let us start with some easy thing. So instead of doing this, just think about that how these differences are given. So how this thing is given. It is these are like xn, then xn plus 1 and xn plus 2. So basically they are sort of consecutive integer, consecutive terms only. So what I'll do, I'll try to use this difference. So let us first find this difference. Xn minus of xn minus xn minus of xn minus 1. What would be your xn? Just think about from here. Your xn would be simply, just think from here. If I replace here n minus 2, if I replace n minus 2 here, then I will get xn. And here it will be xn minus 2, and here it will be xn minus 1. So I'm writing it is equals to xn minus 1 plus xn minus 2 divided by 2, and then minus of xn minus. Is that clear? And it will be equals to what? It will be equals to modulus of xn minus 2 minus of xn minus 1 divided by 2. Is that clear till now? See what I've done? I have just written my xn. So if xn plus 2 is given to me, what would be my xn? Just think about that if I replace here n equal to n minus 2, I'll get xn. N equals to n minus 2 here also, and minus 2 here also. So it is xn minus 1. And here you have, sorry, this is and minus of xn minus 1. So this all minus xn minus of xn minus 1 would give you this. Is that clear? Okay, good enough. I think answer. Okay. Now we'll try to use this particular thing. So already I have found that xn minus 1 is equals to xn minus 2 minus xn minus 1 divided by 2. Okay, sorry. Okay. This is clear. Now, what do you think this can be written? So let us try to write this also. So how you can write your xn minus 1? Let us try to figure that out at first. Okay. How to write your xn minus 1? Just think about this. How will you write your xn minus 1? Just think about this. Because we have to somehow create recursions. We have to somehow create recursions. So how would you do that? Okay, so xn minus 1, it is equals to what? So I'll use one thing. See, if I have to write n minus 1, if I have to use n minus 1, I have to write n minus 3 here. So if I use n minus 3 here, what I'll get? I'll simply get xn minus 3 plus, okay, so, okay, so just give. So if I want to write n, if I write n minus 3 here, if I write n minus 3 here, I'll get n minus 1. Here I'll get xn minus 3. Here I'll get xn minus of 2. And this whole divided by 2. And if I subtract, let's say, xn minus 1 minus of xn minus 2, what I'll get? I will simply get, so I'll write it here. So I will simply get xn minus 3 minus xn minus 2 divided by 2. And if I take a modulus, so inside a modulus, I can shuffle these terms. So I can write xn minus 2 minus of xn minus 1 modulus is equals to xn minus 2 minus of xn minus 3 divided by 2. Is that clear or not? So this particular thing, I can write xn minus 2 minus xn minus 3 divided by 2. So I can write this as xn minus 2 minus xn minus 3 divided by 2 square. Because this 2 will come and this 2 is already there. So if I write this instead of this, is that clear or not clear? Please let me know. Okay. Okay. Now, if I keep doing this, what do you think the last terms would be? So clearly these indexes cannot be negative. The last would be x2 minus x1. So if I keep doing this, so I'm writing it here. So I'm writing xn minus of xn minus 1 modulus. It will be equals to modulus of, and you will get why I'm doing this, don't worry, is equals to xn minus 2 minus xn minus 1. Or even you could have done that also. It was fine. 2. And it is equals to, in fact, that was better. Okay. So no issues. So and the last term would be simply x2 minus of x1. And what do you think 2 raised to power would come? What is the power, do you think? See, understand again. Xn minus 1 is what? It is equals to xn minus 2 minus xn minus 1 upon 2, or also you can write other way also. This way also you can write. This way also you can write. No issues. So if you write this way, then this is xn minus 1 minus xn minus 2. This also you can write. Like in modulus, whether you write this way or that way. So if I write this way, I don't think there is any confusion regarding this. I can write this also, don't worry. And we'll use whichever suits us. Till now, I don't think there is an issue till now. Okay, so at the end, you'll get x2 minus x. This is fine. And what power do you expect here? So you see, this 2 came and there's a power 1 here. Okay, so basically it is what? It is equals to, if I write in, let me write it in this fashion only. And here, if I just shuffle the terms, here and there, so what I'll get xn minus 3 minus xn minus 2. Just think about this. So what is happening? This is xn minus 2 and this is xn minus 1. So if you see the relation between indexes, if you just see the relation between the indexes, this is n minus 2, this is n minus 1. So we'll write in one order so that you don't get confused. Otherwise, we'll get confused. Okay. So I'll write in one order. Don't worry. Just give me a minute. I'll write entire thing in one order. Just give me a minute. Okay. So that you don't get confused. So if I'm writing labels in increasing order, then it's good. If I'm writing in decreasing order, then also it's good. But write in one fashion. So xn minus 2 minus xn minus 1 means what? This index, when I add this, so I'll get n minus 1. If I add 1 to this index, I'll get this. Similarly, if I write xn minus 3 minus xn minus 2, I'll get divided by 2 square. Is that clear? Yes or no? Now let me just write for once xn minus 2. What would be xn minus 2? Just think about, just think from this. What would be xn minus 2? So in order to generate xn minus 2, I have to write n minus 4 here. N minus 4 will come, n minus 3 would come here. So xn minus 2 would be xn minus of 4 plus xn minus 3. See, just see here. If I replace n minus 4. Okay, so this is how you'll get. If I subtract xn minus 3, so what do I get? I will simply get that modulus of xn minus 2 minus xn minus 3 is equals to modulus of xn minus 4 minus xn minus 3 divided by 2. So if I write this instead of this, if I write this, but in the same order, see, here the index is n minus 3, here is index is n minus 2. So I'm adding 1 to the indexes. So if that remains the case, I'll write n minus 4 minus of xn minus 3 divided by 2 whole cube. Is that clear till now? Is that clear? Should I write it? Good. So what will I do? See, if I go on a decreasing trail, at then what should I get? I will get at the last x2 minus x. Now just think what will be the power of 2. What would be the power of 2? See, again, see, why I have written in this form so that you don't get confused. So see, xn minus 1. So here is n, here is n minus 1. Okay. Or if you want to shuffle it, you can shuffle it also because this is modulus. So I can write it as this way. This is one and the same thing. Now, this xn minus 2 minus xn minus 1 upon 2 की power 1. Then xn minus 3 minus xn minus 2 upon 2 की power 2. xn minus 4 minus xn minus 3 upon 2 की power 3. And at the end, you are getting x2 minus of x. So in all of these terms, you see, if you just observe this term, see, is coming as a power here. So whatever you are subtracting from this n, you can see it as a power here. Whatever you are subtracting from n, you can see as a power here. Whatever you are subtracting from this, you're seeing it as a power here. Is that clear or not clear? Whatever you are seeing here, you are seeing, see, 1, what is 1? 1 is n minus of n minus 1, right? So you're going to get n minus 1. Is that clear? Yes or no? Where are the other people? They're not responding. What happened? Okay, you can see this. So in any case, what am I getting? I'm getting that my xn minus 1 minus of xn is equals to modulus of, now this is b minus a divided by 2 raised to power n minus 1. Okay, I was adding something. So sorry. This would be x1 minus x2, right? My mistake, my bad. See, n minus 4 and this is n minus 3, right? So n minus 4, if I add 1, I'll get n minus 3, right? So sorry. So just see the indexes. Just keep an eye at indexes. So here index is n minus 2. Here this index is n minus 1. So what am I doing to indexes? I'm adding 1. So again here n minus 3. Here you're getting n minus 2. So what have I done? I've added 1 in indexes. Just think about indexes. Index of x, the subscript on x. So the last term, instead of x1 minus x2, if I am going in the same pattern, I have to write x1 minus x2. Is that clear? So sorry. See, xn minus 4 plus 1. Only then I'll get n minus 3. So this x1 plus 1, I'll get n x2. So I think there would be n minus 2 here. I'm so sorry. Is that clear or not? So this is how you recognize a pattern. Otherwise, this becomes very difficult in the exam. So obviously, this is not going to come in the exam, but just to exercise your brain, I'm doing all these things. If you just is that clear or not? Please let me know. Otherwise, it will be quite difficult for me to work ahead. Okay, so in any case, what I have found that xn minus of xn minus 1, or you can write xn minus 1 minus of xn in the pattern that we've written. See, what the pattern we have followed is, the pattern that we are following is that the indexes, just see the indexes, is equals to modulus of b minus a divided by 2 raised to power n minus 2. And why am I doing this? I'll come up to this. Now you see, whenever, if you see my previous lectures also, whenever I had to prove this Cauchy sequence, so I was using that xn minus of xm or xm minus of xm, which this particular thing I have to estimate. We have to estimate xn minus of xm, where when n is greater than m is greater than some natural number m naught belongs to. So I have to estimate xn minus xm such that n is greater than m. And if this estimate is less than epsilon, then I'll say that my xn is a Cauchy sequence. Is that clear? I think these are difficult questions, but okay. One thing is clear, I think. Okay. Now what I'll do, I'll play a trick. So what I'll do, I'll write xn minus of xn minus 1 plus xn minus 1 minus xn minus 2. And just I'm writing it for you here. N is greater than m. So here your m is, here it would be m plus 1. Here it would be m plus 2. And dash, dash, dash. Here it would be n minus 2. Here it would be n minus 1. And here it would be n simply. Okay, this is one thing that you can say. Now what I use triangle inequality for here. Is that clear till now? So I know that this particular sum would be this particular sum modulus would be less than equal to xn minus 1 minus xn mod. Again, I'm writing it in the fashion that we've written. Xn minus 2 minus of xn minus 1 mod plus xn minus 3 minus of xn minus 2 mod dash dash xn plus 1 minus of xn plus 2 mod. And this is xn minus of xn plus 1. Triangles inequality. I hope it is clear. And I know that this particular thing, xn minus 1 minus xn is less than equal to modulus of b minus a divided by 2 raised to power n minus 2. Just now we've done it. What it will be equals to, this will be equals to b minus a modulus. This is fine. Just think about xn minus 2 minus xn minus 1. So xn minus 2 minus xn minus 1. Just see. Xn minus 2 minus xn minus 1 modulus divided by 2 is equals to x1 minus x2 divided by 2 ki power n minus 2. Take this 2 there. So if I take this 2 there, so from here it is quite clear. I'm writing it here itself. So from here it is quite clear. that xn minus 2 minus of xn minus 1 modulus would be equals to modulus of b minus a divided by 2 raised to power of n minus 3. You just take 2 there. I mean, just take this bracket and take this bracket. Compare these two. I hope it is clear. So I'll write it here. What I'll write here, I'll write modulus of b minus a divided by 2 raised to power n minus 3. And I'll keep doing this. N minus 3, sorry. And this will be modulus of b minus a divided by 2 raised to power n minus 4. And so on and so forth. And what this would be? What this would be? xm minus of xm plus 1. Just think about this. xn minus xn minus 1 is equals to x1 minus x2 divided by 2 raised to power n minus. So I'm writing it here. See, I hope now it is not getting complicated for you. See, xn minus of xn minus 1 modulus, it is equals to modulus of b minus a divided by 2 raised to power n minus 2. Just a term before. So in that, I have to add, instead of n, I have to add n plus 1. Is that clear? So instead of n, if I replace by n plus 1, what will get? xn plus 1 minus xn modulus. It is equal to b minus a modulus divided by 2 raised to power n minus. Is that clear? So this particular term is similar to this, sorry. So the last term would be minus b minus a modulus divided by 2 raised to power of m minus. I hope it is clear till now. If it's not, please let me know. So we are estimating xn minus of xn, where n is greater than m is greater than equals to, let's say, some natural number n. This we'll see, but we are estimating it in the terms in particular for all n greater than n. We want to estimate this. Why do we want to estimate? We want to see whether this sequence is a Cauchy one. I hope it is clear. Okay, so I'll wait for responses and then I'll proceed. So xn minus xn would be less than equal to, just take b minus a modulus common, and instead inside you are getting 1 upon 2 raised to power of n minus 2 plus 1 upon 2 raised to power of n minus 3, then 1 upon 2 raised to power n minus 4 and dash dash 1 upon 2 raised to power n minus 1. What is the way ahead? Just take the highest power common. Just take the highest power common. So if I'm taking n to be greater than m, so highest one would be this, clearly. You can clearly see that this would be highest because see, m is small. If m is small, so something being divided by small is bigger. So basically n is large than m. So obviously this is the biggest term. So I'll take this common out. And here what I'll get? I will simply get, if I write this series from here, 1, just a term before would be 1 upon 2. And here the terms would be, the last term, this term would be 1 upon 2 raised to power of n. So if I take this particular fellow common out, then this particular term, just think about this particular term. This will be 2 raised to power n minus 1 divided by 2 raised to power n minus 2, which is 1 upon 2 raised to power n minus m, and minus 2 plus 1 is, I think, minus 1. I think the last term would be this. I hope this makes some sense to you. Okay, so basically xn minus of xm, we all understand we are estimating this for all n greater than m, is less than equal to b minus a modulus divided by 2 raised to power m minus 1. Okay, and just think about this series. What do you think this series is? This series is a geometric series, isn't it? So geometric series sum is 1a minus 1 upon 2 raised to power. How many terms are these? So it starts from 1 upon 2 raised to power 0. So these are n minus m terms. Because Always remember, if I calculate from 0 to some point, let's say n, then total number of terms are n plus 1. So basically these total number of terms are n minus m minus 1 plus 1 upon 1 by 2. Okay, this is how you're going to write. And certainly I know that xn minus of xm modulus will be less than equal to, just think, if I'm subtracting something, let's say 1 from something, I'm subtracting 1 from, I'm subtracting half from this 1, isn't it? So I can write that this particular whole thing would be less than 1, isn't it? I'm subtracting some number, just which lies between 0 and 1. So obviously this entire number would be less than 1. So I'll write it is less than equal to modulus of b minus a divided by 2 raised to power m minus 1. This entire thing is less than. Now you just think, as m tends to infinity, b minus a modulus divided by 2 raised to power m minus 1 goes towards 0. What does it imply? It implies that modulus of b minus a divided by 2 raised to power m minus 1 minus 0 modulus can be made less than epsilon for all m greater than some natural number. This is from the definition of the convergence of sequence. If I'm saying that my sequence is converging to 0, implies the distance between the terms of the sequence and 0 can be made less than epsilon after some natural number. So I can write that xn minus xm mod, which we were evaluating for all n greater than m, can be made less than epsilon for all n greater than m greater than equals to m naught belongs to natural, implies sequence xn is a Cauchy sequence. Therefore, it is convergent. I hope it is clear, or is it not clear at all? Okay. Now, question arises: how do you find limit for such sequences? How do you find limit for such sequences? And then we'll end this lecture up. So, how to find limit for such sequences? Okay. So let us try to find the limit. So limit, how will I find xn plus 2 is equals to xn plus 1 upon 2. Okay. So this was what it was given. Now what I'll do, I'll try to do something. Let's say I'll place n equals to 1. So I'm getting x3 is equals to x1 plus x2 divided by 2. Okay. So now n equals to 2. It is x4 is equals to x2 plus x3 divided by 2. N equals to 3. x5 is equals to x3 plus x4 divided by 2. N equals to 4. This is x6 is equals to x4 plus x5 divided by 2. And if I keep doing so, let me do it till last and second last term. So this will be xn plus 2 will be equals to xn plus 1 upon 2. And just a term before would be xn plus 1. And how do I get xn plus 1? By placing n equals to n minus 1. So if I place n equal to n minus 1, okay, this is it. Now what I'll do, add all these. Add. So what you'll get x3 plus x4 plus x5 dash 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 xn plus 1 plus xn plus 2. And just a term before, you'll also get xn. And this entire thing equivalent to, just think, x1 by 2. So there is an x1 by 2 which is saved, plus x2 by 2 and plus x2 by 2. So you have this x2. Then x3 by 2 plus x3 by 2, you get x3. x4 by 2 plus x4 by 2, you'll get x4. Similarly, x5 by 2 and x5 by 2, you get x5s. And I'll keep adding on. At the end, what you are going to get, xn plus 2 plus xn plus 2, you're getting xn, and this term will also be there. So this will be like xn plus 1 divided by 2. I hope you're getting this. Now, if you just think x3 gets cancelled with x3, x4 get cancelled with x4, x5 gets cancelled with x5, xn gets cancelled with xn. What are those terms which are remaining? This xn plus 1 upon 2 remains. This remains. So I'll write this is xn plus 1 upon 2 plus xn plus 2. It is equals to x1 by 2 plus x2. Already I know that my x1 is, I think, x1 was given as A and x2 was given as B. And as n tends to infinity, this tends to L. So this is 3L upon 2 is equals to A upon 2 plus B. And therefore, you can say that my L is equals to A plus 2B upon 3. I hope it is clear. This particular question we are going to do using the subsequence approach also. Okay, so that is an easier approach than this. This is literally a difficult one. But I have done quite many questions on this line in your Cauchy sequences. All those who have not seen those lectures, kindly see those lectures. You'll be able to get this approaches. I have used quite many times, especially in contractive sequences. I've used. So I hope to meet you tomorrow. I hope you're getting all these things. Kindly let me know your feedback. Till then, take care. Bye-bye.